Point is that there are 60 questions on the final. 60 questions on the final. And then on the instructions, you guys can see how many of each we're going to see on the final. Let's see. So, for example, you guys see here that it says questions 1 and 2. All right, so we see that questions 1 and 2, so on the final, there are going to be 2 of these. State if the triangles in each pair are similar. If so, state how you know they are similar. Complete the similarity statement. So rules that we knew at this moment were angle. That's one of the rules that we learned at the moment. If two triangles have 2 angles that are identical, then the triangles are similar. Another one that we learned was side. If 3 sides are proportional, then the 2 triangles are similar. And then the other one that we learned was side. So we're trying to match one of those rules. When it comes to angles, the angles have to be the same. When it comes to sides, the sides have to be proportional. What I mean with that is if we look at the small triangle, I see the numbers 9 and 10. So I'm just going to list my numbers 9 and 10 from small to large. I notice on the big triangle, my numbers are 36 and 40. I'm going to list them from small to large, 36 and 40. We call this proportional if my fractions reduce to the same thing. 9 over 36 simplifies to 1 over 4. 10 over 40 simplifies to 1 over 4. So the sides are proportional. So I'm using 2 sides per triangle. Not only that, but the corner G, the angle G, happens to be on both angles. If I look at angle G, it is an angle from the small triangle, but it's also an angle from the big triangle. So if you notice, I have 2 sides and the angle in between. Let me simplify this real quick. So I'm going to complete this by side, angle, side. Or notice my 2 sides were proportional, the angles in between the sides. And I'm going to say GFE is similar to GLK by side, angle, side. Any questions on this one? Once again, there's 2 of these on the final. Then questions 3 and 4, we have that the polygons in each pair are similar. So they're telling me that already they are similar, so the sides must be proportional. Find the missing side length. So from one of the figures, I'm going to use these 2 numbers, x and 24.5. So I'm going to make a fraction out of it, x and 24.5. I notice that x on the other figure becomes 16. 24.5 becomes 9.8. So now what I'm going to do, I'm just going to cross multiply. I'm going to go 9.8 times x gives me 9.8x. 16 times 24.5 gives me 392. Obviously, to solve for x, let me divide both sides by 9.8. And I get that x is equal to 40. Once again, the figures are similar, so the sides are proportional. Any questions on this one? Now this next one, questions 5 through 6 from the final, 3 on our review. Find the missing length indicated. Leave your answers in simplest radical form. Here, I know when we covered this figure, I told you guys that there were 3 triangles. We're really looking for for only 2. So I'm going to draw 2 triangles here. I'm looking for 2 triangles where I can see 2 measurements. If I look at this one, this is 36, this is x. So if you see, I'm looking at this little triangle. Here's my 90-degree angle. X happens to be the hypotenuse, 36, the smaller side. So here's X, here's 36. Right, if you notice, I have the small triangle. Obviously, flip it a little to match that figure. Now, another triangle that I have, I see my middle triangle here, but unfortunately, in the middle triangle, I only have one side. I don't have the other two, so I cannot use that one. So the one I'm going to end up using is the big triangle. On the big triangle, let me highlight the big triangle. I notice that the small side is X and the hypotenuse is 100 because I'm looking at the whole thing, right? 64 plus 36, the whole thing is 100. So the hypotenuse is 100 and the small side is X. Now that I have the two triangles that I needed, I'm gonna, from the first triangle, I'm gonna make a fraction, 36 over X. And I notice that 36 becomes X and X becomes 100. Cross multiplied. X times X, I get X squared. 36 times 100, I get 3600. To get the X by itself, let me get the square root on each side. And I'm going to get that X is equal to 60. Any questions on this one? All right. Now, on the final, we're going to have questions 7 through 10. So 3 questions. And on the review, I gave you guys 3 as well. Just because I want to review the 3 figures that you guys will be able to look at. It says find the area of each. The first thing that I'm giving you guys is a triangle. To find the area of a triangle, we look for the 90-degree symbol. Sometimes it's inside the triangle, sometimes at the corner, sometimes outside of the triangle. But we look for the 90-degree symbol. And we're going to multiply the two numbers that make the 90-degree symbol. In this case, 3.4 times 7. So that's the first thing I want to do. Multiply the two numbers that cross at 90 degrees. Then, from my result, whatever I get from that, I'm going to divide this by 2. Because a triangle is half of a rectangle. Right? If I multiply those two numbers, it gives me a whole rectangle. So I'm going to multiply these two, 3.4 times 7. And whatever I get, I'm going to divide it by 2. So let me see, 3.4 times 7 divided by 2. It gives me 11.9. Once again, on a triangle, you multiply the two numbers across 90 degrees, and then you divide it by 2. When it comes to a rectangle, you just multiply the two numbers across 90 degrees. I see a 90-degree symbol here. It is made by 6.5 and 11. So I'm just going to go 6.5 times 11. There's no dividing by 2 on this one. It's just 6.5 times 11. And I get 71.5. When it comes to a parallelogram, which looks like a slanted rectangle, treat it the same way you would treat a rectangle. Multiply the two numbers across 90 degrees. In this case, 3 times 11. And my result should be 33. I gave you guys the three figures that you guys will see. I know we also covered trapezoids when we were covering this, but I'm going to take trapezoids out of the final. But I'm giving you guys one of each on your test. You could get one of each. You could get 3 of the same, right? Or 2 triangles, 1 rectangle. It's a combination of the 3. But on the review, I decided to do 1 of each. That way we covered them all. But on the test, it's a combination. Now, question number 7, we have a regular polygon. It says find the area of each regular polygon. Round your answer to the nearest tenth. Formula that we learned here was 1/2 times the apothem, and the apothem is this 12.9, that distance. So 1/2 times the apothem times the perimeter. Perimeter is the distance around the figure. So for a calculator, 1/2, I'm going to call it 0.5. And I'm going to multiply this with 12.9, which is the apothem. And I'm going to multiply this with 10.7 times 8. Because that's the perimeter, right? Each side is 10.7. There's 8 sides. So 10.7 times 8 is the perimeter. So I'm just going to multiply all that. 0.5 times 12.9 times 10.7 times 8. My answer happens to be, on the calculator I get 552.12. But because I'm rounding it to the nearest tenth, I'm going to say 552.1. Any questions?